Hello everyone and welcome to Women on Stage Global Virtual Conference 2023. My name is Kristina Devochko, and in this session I would like to give you a brief introduction of chaos engineering, what it is, what kind of value it brings to the tech industry, and I hope that at the same time we can have a little bit of fun while we learn more about the topic. So buckle up, and with no further ado, let's kick it off. Before we start talking about the chaos engineering itself, I would like to share a few words about who I am and what I do. I am based in Oslo, Norway, and am working as a principal cloud engineer at Amesto 42. I'm also a Microsoft Azure MVP and CNCF ambassador, and I love contributing to the tech community in different ways, and one of them being today at the Women on Stage virtual conference. If you would like to have a chat about any of the topics related to cloud native, Kubernetes, green tech, chaos engineering, you're very much welcome to reach out to me. I will share some of my contact information in the end of this presentation, or you can also find it at Women on Stage website. Alright, but enough about me. Let's talk a little bit more about chaos engineering. Some of you might have tested it out yourself, or might have read or seen some discussions about the topic on different social media platforms or on different technical forums. And the thing is that chaos engineering has been known to the IT industry for quite a few years, but it has really gained popularity in the last few years, and there are quite some good reasons for why this happened. So if we were to look beyond the fact that chaos engineering is a cool and popular term, what is it actually at its core? And in order to understand that, we would need to look at the modern landscape of software development. And nowadays we are building quite complex distributed systems. We are running our applications on public cloud or even multiple public cloud platforms. We may be integrating applications that are running on public cloud with applications running on premises, where we enter the world of hybrid cloud. And when we are developing applications, we are integrating tens or even hundreds of third-party libraries. Our applications may be integrated with tens or hundreds of third-party services. Even the infrastructure that the public cloud provider offers us, where our applications are running, is also a third-party component that our system contains of. And when we look at it, in total, the web of interconnections and interdependencies here becomes really vast, and there is a big amount of bits and pieces that really need to play together in order for our applications to be successfully developed and used by the customers and users worldwide. And at the same time, the world does set quite high expectations to the modern applications and services. It is expected that those are available, performant, secure, and scalable at all times, 24/7. And the cost of downtime can be huge. If we think about the critical systems, for example, in the financial industry or in medicine, it can even cost lives. So avoiding downtime is the goal of every single company, because you can lose reputation, you can have huge fines, you can have a lot of potential issues in case you will not be able to kind of handle downtime and outage and minimize it to the maximum possible extent. And the level of responsibility there is therefore quite huge on those of us who are developing these applications and systems. And those of you who are working with service level agreements kind of get this nasty goosebumps at this point, because you understand exactly what I mean by the cost of downtime. And the picture here becomes pretty scary. So what chaos engineering does and how it comes into picture in this case is that it provides, it is a discipline that provides us tools, provides us approaches that we could utilize in order to simulate potential downtime, simulate potential outages, simulate potential failures that may happen in the application, in the infrastructure, in the different system components, so that we can be prepared for when these disruption scenarios actually happen in real life. We can, in a controlled manner, perform something that's called experiments, where we could create such disruptive events, see how our system behaves, see how us who are involved stakeholders behave in case these disruptions happen. And by that, we can gain that hands-on experience. We can be more prepared. We can identify areas where we can improve our systems, our applications, where we can integrate additional self-healing mechanisms or additional redundancy, or find other ways that we can make our systems more resilient, more prepared to withstand such turbulent events, and therefore gain more confidence in our system and be more ready when such scenarios happen in real life. And therefore, chaos engineering tools and methodologies can help us make this picture a little bit less scary and get more prepared. And chaos engineering is inspired from mechanics and mathematics and from the area called chaos theory, which bases itself on terms like butterfly effect, which some of you might have heard of, where a change in one part of the system may have larger changes, may cause larger differences, or may cause challenges in a different part of the system. And this can be nicely applied also to the modern landscape of the modern software and systems, due to that interconnection, to this large web of dependencies, to that large level of distributed setup. We need to have better ways to ensure that changes that happen in one part of that distributed system do have minimal possible effect to the rest of the system, and that the rest of the system is desired and should be functional, even if there is a change or an issue in a small part of it. And we are also developing new functionality quite rapidly and rolling it out frequently, and that's when it becomes even more challenging to ensure that those rapid changes actually do not affect the stability and availability of our systems. So we need to have ways to test and ensure that the changes we are adding up, that we have control of, also are added up in a secure and stable manner without affecting the overall state of the system. And that's also where chaos engineering can really come into play and bring its benefits. And as I mentioned, chaos engineering has been known to the industry for quite a few years, dating back to 2003, when Amazon has created an activity called Game Day, which I'll also mention later in this presentation, where during a day, a different set of stakeholders gathered together and kind of created these activities that would simulate disruptive events, and they would test kind of like a tabletop exercise, if you have heard it from the cybersecurity domain, where you would kind of test how you react and the others in the team who are affected by the disruptive event, how you would handle that event, mitigate it, how your systems would react to that disruptive effect or that disruptive event, and then you could analyze and kind of have a retrospective on what's happened and find ways to improve, so that next time the output would be even better in case a similar scenario takes place. But chaos engineering also got more popular in 2010, when Netflix created a tool called Chaos Monkey, which they used to test their own systems and infrastructure. And Chaos Monkey was a tool that would randomly turn off a server, and then you could observe and react how the rest of the system adjusts and adapts to the changes that happened, and how the rest of the system is, how stable it is, and how available it is in case of such events. So it could kind of get a clear, give a clear picture of potential improvements that may need to be done to ensure that the system is not largely affected by the fact that one server is turned off, or multiple servers potentially. And in 2012, Chaos Monkey tool was open sourced and kind of came out to the benefit of a broader tech community. And now we're looking at quite a large landscape with multiple tools of different kind, and in general where chaos engineering methodology and activities are being adopted by more and more organizations worldwide of different sizes. And these days we can see dedicated conferences like Chaos Carnival and Chaos Conf that are kind of dedicated specifically to knowledge and experience sharing in the domain of chaos engineering. And since 2014 you can actually also be hired into a position as of a chaos engineer, where you would kind of be working tightly with site reliability engineers, or this may be a variation of an SRE position. But I think it's also quite a cool title to have, though I think that many SREs may have these chaos engineering related activities as part of their daily work as well. But the whole point of the chaos engineering, the whole goal of it, is to provide you ways to perform controlled experiments, to simulate disruptions and failures in a controlled manner, to gain more knowledge about your system, to gain more confidence in your system, and to detect places where you could improve to make your system more prepared for the real life disruptions. So managed trouble in a way. So this is what chaos engineering is at its core. So if you were to start looking into integrating chaos engineering practices in your own projects and organizations, what would be important to think about and be prepared for? And for that, I would really recommend to check out the Principles of Chaos.org website, where the chaos engineering principles are currently defined and maintained by the tech community. So that is a document that goes into more details about the main goal of chaos engineering and its main principles, as well as it provides some good argumentation for every single principle. But if we were to shortly sum up what you would need to think about when you are kind of planning the chaos engineering experiments and would like to start working with it in your own organization, I would say that the main principle is to kind of have a goal of getting your system to such a steady state that it is hard to disrupt it with the experiments you create. So the harder it is to disrupt the system with the experiments, the more confidence you can have in that system will be able to withstand potential failures and outages that may happen in a real life scenario in production. But in order to get there, you need to go through a few stages and through quite a few experiments to identify the ways you could improve that system and get it to that high level of steadiness. And first of all, in order to build efficient experiments, in order to be able to kind of detect where you need to improve, you need to understand what you would like to disrupt, what you would like to test, because the systems and applications are different. So first of all, you would need to gain that knowledge and understanding of your system, your applications, how those are built up, and what bits and pieces those contain of. Once you gain that knowledge and involve other stakeholders who may help you gain that knowledge and that overall picture, you can start by understanding what defines a steady state in your system, at which measurable metrics your system can be identified as healthy, as stable, as steady. So you would start by what scientists call building a hypothesis around the steady state. So you would need to find those measurable metrics that could help you, that will establish a baseline for you that you can work out of. They will provide you information on when your system is healthy, so that you can create real world event simulations. You can create those disruptions that will try to change that state, but without having that baseline and understanding of when, based on which numbers, based on which metrics your system and applications are actually stable, it will be difficult for you to build experiments that would try to change that behavior. So you would need first to gather and establish that baseline to work from. And then you would need to look into creating those experiments, those simulations, and starting small. It kind of goes, minimize blast radius is one of the principles of chaos engineering. So it means that when you are creating those event simulations, you would need to minimize the kind of impact that event could have. And over time, you can expand the kind of radius of that experiment when you take it step by step with small pieces at a time, so that you gain even more knowledge of your system and more experience with it. So the whole process would become really controlled. And then I often get asked, and you may also have read about it when you hear about chaos engineering, like testing in production, running those experiments in production. And yes, one of the main points and value you can gain of running chaos engineering experiments is to run those in production systems, because most of the environments that are non-production still have quite some differences and deviations compared to the production level system. So you still don't have that 100% confirmation that the same experiment will not give you different results in production. Therefore, it is a very normal practice with time, long term, when you have understood and got a lot of hands-on experience with chaos engineering in pre-production environments, to integrate those in production systems, as long as it is done in a controlled manner, and as one of the principles states, minimize blast radius, so that you test single, smaller area, smaller part at a time. Then you can do it with kind of that security that you will minimize disruptions that can affect your customers or users, so that you can potentially do those experiments when the traffic is lowest, for example. And this is something you would need to look into as part of your own project, and depending on those factors of how critical the system is and how much activity there is, depending on the day. But the point is that you will gain most value when you are actually performing those experiments on production environments with the exact configuration of the systems that are being used by the users. So that's when you can gain that 100% confirmation that the system will be able to withstand those events. But this is not something you would start with straight away when you don't have much knowledge or experience about doing it in pre-production environments. And of course, long term, you should look into ways of automating those experiments so that you could run them continuously. And this, you could gain also value from that due to the frequent development and rapid changes that may be added up to the software, to the applications, and also to the infrastructure and the way those applications are running in public cloud or on premises or on any other infrastructure. Because the system is never at a static state, it changes all the time, and it means that the experiment that worked once and your system was able to kind of pass successfully, it is not given that with the new changes, with the future changes, it will still be able to pass that experiment. So having ways to run those experiments continuously and ways to minimize those manual changes can also bring you a lot of value, so that you can also see how the system behaves over time. And many modern chaos engineering tools out there do provide that capabilities of automation as well. So if we reiterate on kind of the value of chaos engineering as a discipline, why would you want to apply it in your projects and organizations? With help of chaos engineering, you can simulate production-like disruptive scenarios, which can help you build a higher level of reliability and confidence in your system, and ensure that you even increase the availability of your system even more. You can help with identifying the ways to improve. You can find ways to build your system to be even more mature by introducing additional self-healing mechanisms, for example, or retry mechanisms, or having redundancy in case, for example, of a region outage or an availability zone outage. So with those, without testing that, without simulating those production-like disruptions, you will not be able to know necessarily where you would need to improve. So these chaos engineering provides you ways to identify those areas and build a more resilient system and more resilient applications. Most enterprises, most companies must have a disaster recovery plan, a business continuity plan, in case of different disasters, in case of different disruptive events that may happen. How would your system react? How much time it would take for a system to be back up and running? How will you handle potential data loss? How do you prevent potential customer data loss? To make it even more practical, you could have those game days, you could have those production-like simulations with such chaos engineering experiments, where you can also test how your teams react in case of a disruption that happened, how your systems react to it, and what is kind of the current outcome and how can you make that outcome better. So this can be a real hands-on tool for you to improve your disaster recovery and business continuity plan routines. And by performing chaos engineering experiments, you also get to collaborate with other teams, because one person does not have all the knowledge about a system. So different teams may have best knowledge about different areas of the system, and only together with collaboration you could get that needed overall picture of the system and how it hangs together, and learn out of it together how you can collaborate to improve that system over time based on the results you get from those experiments. Chaos engineering experiments can also be of help when you want to test your level of observability and transparency of your system. For example, how well are the traces? How well are the current metrics that you have injected in your applications and in the infrastructure, for example? Is it enough? Are there places where you haven't seen any useful messages and warnings, and where you haven't received any necessary alerts while the experiment was ongoing? Are there places where you are missing something that you should add or improve the current alert or the current trace message, for example? So this can also help you understand if there are any areas of the observability of your system where you can improve. So you don't need to wait until this actually happens in production. And even in security domain, you can also gain benefits from running chaos engineering experiments, because by creating disruptions, by taking some services offline, you can also see how the other services, the other components react. Do they suddenly spit out unnecessary, potentially sensitive information like call stacks? Or how does that part of the system or that application react to errors in the service that it's dependent upon? Will I be able to utilize that outage as a benefit to get deeper into the system, to gain more access, for example? It's kind of an additional penetration test related activity that you can use in combination with other security related activities to also test if you get any potential vulnerabilities or security holes, if you can see any of them suddenly becoming visible due to these disruptions. So once again, you can be able to shift left and identify those earlier in the software development lifecycle, and until this may potentially happen in production. So there are quite many areas where you could apply chaos engineering routines and practices. And if we go concrete to the areas where you could apply that based on kind of the whys that I have talked about right now, so you could apply it as part of the security testing of the applications themselves, and also the environments where those applications are running, be it a Kubernetes cluster or some, for instance, PaaS services and public cloud, or bare metal servers, for example. You can test how good your visibility level of your application and systems are, how observable those are. Are the traces enough? Are the metrics enough? Are they detailed enough? And are you having a good level of alerting that actually is meaningful? You can use it as an additional method of testing to perform stress tests, to perform performance testing, load tests, and you can use it to improve disaster recovery routines and perform those real-life simulations to test that your disaster recovery plan actually works. And you could use it as an additional way to ensure that the quality of the changes that are being added to the applications and to the environment configuration are good enough and have minimal level of impact on the rest of the system. So this can be a useful component as part of the software development lifecycle, and can give benefits to multiple teams, where you could gain a lot of useful information about your system and use that information in order to make your system more resilient, more future-proof, and prepared for the outages. And then in the long term, by doing that, you maybe will even be able to withstand quite many of the scenarios which you wouldn't be able to do without performing such simulations. So I would totally recommend testing it out for yourself and see what kind of knowledge you can gain about the behavior of your own systems and applications, if you could use that knowledge to your power. By going to the dark side of chaos engineering and creating controlled disruptions, you can actually bring more light and more confidence into your system. And how can you do that? As I said, there is a multitude of different tools, chaos engineering tools out there that you could utilize, and you could do it in the formal way, a more enterprise level way, and you can also do it in the fun way, because I promised that we were gonna have some fun today. And these are just a few of them out there and are available. And even though quite many tools here are focused on Kubernetes because it is so widely adopted, so popular these days, but there are also tools that you could use to also test components outside of Kubernetes that are not Kubernetes cluster specific. Like for instance, Azure Chaos Studio could also help you test other Microsoft Azure PaaS services, or you could use Chaos Monkey to also test virtual machines, for example. And in the fun way, I would like to highlight that there are quite a few cool tools out there that the community has created that you could use for presentations, to make an impression about what chaos engineering is, but also to learn main principles of chaos engineering in a gamified way. For example, like you have Cube Doom based on the known Doom game, or KubeInvaders that I'm gonna show you shortly, which is based on Space Invaders game if you have used that one. And there is even a tool that was created for the KubeCon 2016 demo, which was Kubernetes in virtual reality, where you could perform those chaos engineering experiments like killing pods in the virtual reality setup. So that was quite cool. And on the formal side, we have quite a few different tools. Some of them are paid, some of them are open source, like Chaos Monkey, for instance. But we also have two CNCF, two open source projects that are governed by CNCF, which are Litmus Chaos and Chaos Mesh, which I will also show you shortly. And Azure Chaos Studio, for instance, their Kubernetes experiments, which you could use to test, to perform experiments on Azure Kubernetes service clusters, those are based on Chaos Mesh. So some of these tools are quite widely adopted and used by quite many organizations. So I would totally recommend to check those out, and I will share some useful resources with you afterwards. So we've come to the point where it's time to do some experiments ourselves. So let's get to it. Let's see. First of all, what you can see here is a quick setup which I would like to use to show you some very simple concepts, some very simple scenarios that you can quite easily start with to gain more information and more understanding of what chaos engineering is. So on the left top side, you can see that I have created a simple application, which is a Chaos Neon Cat. And on the right hand side, I have deployed a tool on a Kubernetes cluster, which is called KubeInvaders, which is a chaos engineering tool that we could use to simulate outages to the pods, which are basically the applications that are running in Kubernetes clusters, or to the nodes, which are servers, virtual machines that those applications are running on in Kubernetes cluster. And don't worry that you may not, if you haven't worked much with Kubernetes, I will not go into details of the Kubernetes specific concepts, so you should be fine. But if not, don't hesitate to reach out to me afterwards. So what we will do here, you can also check it out at your own time. I will not go into all the details here, but you are also able to configure a more granular way you would like to perform stress tests on those applications or servers in a Kubernetes cluster. We will do it pretty simple. So we will just try to kill our application that has currently one copy of itself running in a Kubernetes cluster. And then we will see what kind of learning this information will provide for us. So currently you can see here that the aliens are the pods, so the applications that we are running in our cluster, and these servers represent the nodes, the virtual machines where those applications are running. And we are targeting just a specific namespace in the cluster to know, as we saw in the chaos engineering principles, to minimize blast radius. So I don't want to cause disruptions to the other applications in the cluster. Therefore, I will only target the namespace where my application is currently deployed. So we don't want to target the nodes, the servers today, since we will start small. So I have disabled the node targeting right now, and as you can see, we only have a copy of our application. On the left bottom side, I have the terminal where I am connected to my Kubernetes cluster. So what I can do is that I can monitor what will happen with those application replicas in my cluster. I can do that by getting my pods from the chaos neon cat namespace, and I would like to watch them and see what will happen. So now I will put it to be auto-refreshed every second so that we can see if any outage will happen. And what we can do? We can start shooting. And as you can see, with one replica of our application, it's no surprise that the application actually becomes unavailable, offline. And as you can see here in the bottom side, our replicas were being terminated and then being recreated once again, which is kind of how a simple disruption like killing an application works. So what kind of information does this give us? It gives us information that one replica may not be a very available, a very scalable way to, a very stable way to run our application with. So what can we do? Well, we can increase the amount of replicas that our application is running with. We can increase it so that it is more difficult. If one instance of an application fails, we still have a few others that will keep the application online, will keep it up and going. So in this case, I can do that by editing the deployment definition of my chaos neon cat application with kubectl edit. Here I will not go into the details, but I will go down in the deployment definition to the replicas field and change it to 5, so that now we can have 5 instances of our application up and running. And as you can see on the right hand side, the amount of variance does also increase. So what can we do now? Now we can try to kill those and see what will happen now. As you can see, for me it is much more difficult now to get all those instances out. And as you can see, right now the result is totally different. Now, as you can see, it actually happened a single time, but it does also give us information that it was much more difficult to kind of take our application offline. And then we could look into further ways of how we could work with this application and improve its availability even further. And here also on the right hand side, you can get information in the latest log about which actions were performed, so that you could kind of have the audit log of the changes you have done through this chaos engineering tool yourself. So this was a very simple way to test out the gamified version of chaos engineering, which with KubeInvaders tool. So I totally recommend you to test it out and have a little bit fun for yourself. But I would also like to demonstrate how we could apply the same scenario just with an enterprise level tool, which is Chaos Mesh. So let me switch to the different clusters where I have the same application, but it is running in a different cluster that has Chaos Mesh setup, which is a chaos engineering tool that is open source and is governed by CNCF. So here I will also switch to that different cluster. So here we can see if we get overview of all the applications that are currently deployed in the cluster, let's increase it a little bit here, we can see that we also have Chaos Mesh deployed here in addition to our own application. All right. What is good with Chaos Mesh is that it provides us also a dashboard which can be quite useful and very nice to use to perform and plan the experiments. So here we could also get a UI to both create the different experiments and configure them. We can schedule those experiments to run continuously, and we could even plan a workflow where you could map different experiments and chain them together so that you could see how the system reacts if one event happens, and then it may cause an additional disruptive event that may cause the third event, and then you could monitor the whole scenario, the whole workflow of a specific production disruption, and get even more valuable and advanced results out of it. And then you could get that history over time about the different things, different events that have happened, and different experiments that have been performed. And you can also get that visualized over time on the timeline. So as you can see, I have done some experiments here. So if we were to do the same kind of experiment with killing our application, with killing our pod, we can easily do it from the UI. I can do that by doing a new experiment here. And as you can see, first I would need to define where and what I would like to inject, what kind of failure. So you could also do it not only on Kubernetes cluster, but also on the concrete hosts on the servers. So I will choose Kubernetes, and there is a bunch of different scenarios here, but I will choose pod fault. And here we could see different scenarios, both pod kill, but also pod failure, where you could cause a restart, consistent failure over time to your application, so that you could monitor that. So if we go to the pod kill, and we want it to happen instantly, so in seconds, we want it to be deleted straight away, we could do submit. And now we need to provide some information about where we would like to run this experiment. And here I can choose from the namespaces or the applications that are running in the cluster. So I would like to filter that again on Chaos-Nyan-Cat to minimize the blast radius. And then I need to provide the name of the experiment. And I could say Chaos-Nyan-Cat pod kill. And then I could choose a mode. I could just kill a random pod, or I could kill a fixed number of pods or replicas of my application, or I can do it percentage-wise. Let's do percentage-wise. We have only one replica currently, but we could use 80% so that it can kill that pod straight away. And then we could just do submit. Before we do that, we can start refreshing our application, and we could once again monitor our application here as well. Let's do a submit, and now we are ready to start the experiment. As you can see, it started very quickly and completed straight away because it just performed the killing, and the application became offline because there is just one replica, so it just took it out. And you could also use this information to monitor how long time it takes for the application to come back up and running. And if we we can see here, we could also see that kind of the experiment performed in the same way or behaved in the same way like the one we did with KubeInvaders. And last demo I would like to show is that apart from the UI, you could also perform these experiments programmatically, so that you could save them to the source code and have change history and evolve your experiment, the source repository for your experiments over time. And you could also, when you are creating new experiments, kind of define the YAML itself, or even upload it directly here, which can be real useful. So what we will do is that we will perform the other experiment that I showed you here from the templates, which will not kill the pod but will perform a failure, will simulate a failure to the application over a small time frame, a pod failure. So what we will do here, once again, don't get afraid if you haven't been working with Kubernetes here, but what we will do is that we will basically define an object of custom type that Chaos Mesh tool uses. This is the pod chaos object that we would like to define. It will be created in the chaos nyan cat namespace where our application is running, and it will be a pod failure experiment. This experiment would run on the chaos nyan cat namespace where our application is running, and it will perform a failure to a fixed percent of application replicas, which is 90% in this case, and it will perform this failure in the time frame of 60 seconds. So the way you define those experiments programmatically is also quite straightforward and should be relatively lightweight to start with, and there are a big collection of community maintained templates which you could check afterwards as well. So let's create that experiment. Let's apply it in our cluster. So we would do kubectl apply -f and then this. And what will happen is that a new experiment will pop up here and it will be running for 1 minute, and as you can see our application is already offline, and what it will perform, it will simulate restarts. So if we extend it again, you could see that it has been restarted for 10 seconds ago, and this is kind of the way that this experiment could simulate that the application is suddenly going offline or experiencing something. And then it would run for a minute, and then you could, for example, see will additional replicas of the application come up, how much time it will take, and you could use this information to analyze what you can do better. Are the health probes good enough in your application? Are you getting any alerts? Are you getting any useful error messages? And so on and so forth. So you can get quite a lot of information that you could work from going forward. And as you can see, it also restarted two times, and the experiment is completed. And you could also, if we stop refreshing here, if you would like to learn more about the experiment, you don't need to go to the Chaos Mesh UI itself. You could just in your cluster do a kubectl get podchaos, get all podchaos experiments that have been run, and you could see that there was one that we run through UI, which was a podkill, and the one that we have run just now for simulating failures in the pod, in the application. So if I say I would like to get information about this experiment, I could do a kubectl describe. Oh, sorry, I forgot to provide what I want to describe. I want to describe a pod chaos object here. And then I could get information about when it was started, when it was finished, and it can give me information, for example, in order to troubleshoot in case one of the experiments may have failed. So this can also be a more enterprise level tool that you could use to kind of implement production level chaos engineering experiments. All right. This was a very short demo, which I hope was a little bit of fun. So do check out those tools at your own time as well, and experiment a bit with those. We are coming towards the end of this session, and therefore I would like to sum up a few considerations about chaos engineering that you could have in the back of your head when you will start working with it in your own projects. To be successful with chaos engineering experiments, it is needed to get some preparations in place to get that overall picture and knowledge of your system, your applications, and how they're interconnected and what kind of dependencies they have. And in order to do that, you need to collaborate with other stakeholders and domain experts, and to get involved with those that may need to get the same hands-on experience and knowledge of how to react in case failures happen, so that those people can also be part of these experiment executions. Testing and performing those chaos engineering experiments in production environments over time will bring you most benefit, because you will actually be simulating very production-like scenarios, and that you could gain most knowledge out when you do it on production environments. But you shouldn't do it straight away, because you do not want to impact the customers and direct users of your system. You need to gain experience, to gain that hands-on knowledge, and to define experiments that are performing disruptions very carefully on smaller areas of the system in a controlled manner. Therefore, you would want to start in test environments and production-like environments first. And it's important to minimize the scope so that you don't get overwhelmed with all the potential disruptions happening simultaneously, that you could minimize the area where you perform those tests, perform those disruptions, and also minimize the potential outages that the consumers and users of the systems may experience. So it's important to do those experiments with care and carefully. Understanding the challenges that your system may experience, you could do that by performing those experiments. Long term, once you get more experience, finding a way to automate those disruption events and running those simultaneously, so that you could also perform those tests when new changes are being rolled out to the applications and your systems, will ensure that your system actually is stable and more mature also over time, with the new changes coming into it. And do check out ways how to use those experiments and integrate those in the tabletop exercises, disaster recovery plan executions, or even a game day event, depending on what kind of routines your organization has in place. With that, I would say thank you so much for staying in with me for this session, for staying until this moment. I hope you enjoyed it, and I hope that you got to learn a bit more about chaos engineering, and hopefully you can take that knowledge further and experiment with those tools like KubeInvaders or Chaos Mesh or any of the other tools that I showed. And I would love to hear about your experiences with chaos engineering as well. And if you have any further questions or would like to learn more about it in a longer session as well, don't hesitate to reach out to me. I will be happy to help out. And the QR code on the left hand side will take you to the GitHub repo, where we have created a list of learning resources that you could use to learn more about chaos engineering. And there are also some templates available that you could utilize to perform and set up some of those tools like KubeInvaders, for instance, so that it's up and running for you to use in your own environment. Thank you so much. I hope you enjoyed it. I hope you had fun, and I will see you next time. Thank you so much. Bye.